Welcome to today's Explainer. We've got something really exciting lined up for you. Today, we are going on what I like to call a dimensional journey. And we're going to start with something as simple as a tiny microscopic dot and literally build our way up to the complex, real-world shapes that make up everything around us. It's kind of like being a builder, right? You piece together basic bricks to construct an entire skyscraper. Well, we're going to break down the basic building blocks of geometry in the exact same way, making them completely effortless to understand. So let's just dive right into this dimensional journey.
Okay, so here is a quick roadmap for our explainer today. We're going to logically build our knowledge from 0 dimensions all the way up to 2D enclosures. First, we'll cover points and lines, then shapes and angles, move into the world of triangles, check out the quadrilateral family, and finally wrap things up with perimeter and circles.
All right, let's dive into our very first section, points and lines.
But, before we even get to the shapes themselves, have you ever actually wondered where the word geometry comes from? It's pretty fascinating. It's derived from ancient Greek. Geo simply means earth, and metron means measurement. So, earth measurement. Back in ancient times, early humans desperately needed a reliable way to measure their land for farming, or to figure out how to design their early architecture. So they basically invented this incredible, practical system to solve real-world problems.
So let's start at the absolute beginning. Imagine a totally blank space. Now, if you take a perfectly sharp pencil and just tap it once onto a piece of paper, that exact location is a 0-dimensional point. It has literally no size, no width, no depth, just a specific location. Now, imagine taking that single point and stretching it out endlessly in opposite directions. Suddenly it becomes a 1-dimensional line with absolutely no beginning and no end. But obviously, we can't measure something endless. So if we just chop out a specific piece of that line so it has 2 fixed endpoints, we get what's called a line segment. That's something we can actually hold and measure. And if we do something halfway in between, like fixing just one point but letting the other side travel on forever into infinity, well, we call that a ray.
Now think about this for a second. It's a fun question. Will 2 lines always eventually meet? The answer is absolutely not. If 2 separate lines happen to cross each other at one single common point, we call them intersecting lines. They literally crash into each other. However, if the distance between 2 lines remains exactly the same forever, meaning no matter how far you extend them, they never ever meet, those are called parallel lines. Just think of an endless set of railway tracks. They run perfectly side by side, but they never cross.
You can actually see this parallel line concept perfectly on a standard everyday ruler. The top and bottom boundaries run side by side but never intersect. But geometry gets super fun when a straight line bends or connects to create a closed curve. The moment that happens, it instantly divides all of space into exactly 3 distinct zones. You have the interior, which is all the space trapped inside, the boundary, which is the line itself creating the fence, and the exterior, which is absolutely everything else in the universe outside of that shape.
Moving right along to sections 2 and 3, shapes, angles, and the world of triangles. So, if you want to effectively trap a flat space, you literally can't do it with just 2 straight lines. You need at least 3, and these closed shapes made entirely of straight line segments are called polygons. Let's break down their anatomy really quickly. The sides are the straight lines that form the boundary itself. The vertices are those sharp corners where 2 sides crash into each other, and the diagonals are those internal crossing lines connecting opposite corners. Now, when we use exactly 3 sides, we create the very first, most basic polygon, a triangle. And triangles have this magical, universal mathematical rule called the angle sum property. Basically, no matter the shape, size, or weirdness of the triangle, its 3 inside angles will always add up to exactly 180 degrees. No exceptions.
Now triangles actually make up a pretty massive family, and we can easily categorize them in 2 different ways, by looking at their angles or by looking at their sides. If we sort them by angles, we have acute triangles, where every single angle is a sharp, small angle less than 90 degrees. We have right triangles, which stand tall with one perfect 90-degree corner, and obtuse triangles, which lean back with one wide angle greater than 90 degrees. But if we sort them by their sides instead, we find equilateral triangles, where all 3 sides are perfectly identical. Then there's isosceles, where just 2 sides are equal twins. And finally, scalene triangles, where every single side is a completely different length.
Here's where it gets really practical. If you want to mathematically draw a very specific, unique triangle, just knowing its 3 angles isn't enough. You could draw a tiny version or a giant version of the same shape. You absolutely need one of these specific combinations to lock its size and shape in place. You either need all three sides, which is known as SSS, or two sides and the angle squished between them, known as SAS, or two angles and the side connecting them, known as ASA. Or finally, if it's a right-angled triangle, you just need the 90-degree angle, the long hypotenuse, and one other side. That's known as RHS. Without one of these exact keys, you literally cannot construct a unique fixed triangle.
All right, let's step it up a notch with Section 4, the quadrilateral family.
Think about what happens when we step up from a three-sided triangle and add a fourth side. Take a look around you right now. Seriously, glance around the room. Can you spot any flat, four-sided objects? Maybe it's a chessboard, your flat-screen TV, the screen you're watching this on, or just the cover of a notebook. These are all real-world quadrilaterals, which just means shapes with four straight sides. Now, let's explore how these different four-sided shapes actually relate to one another in this fascinating sort of evolutionary hierarchy. At the very top, you just have your basic, everyday, four-sided shape. But when the opposite sides become parallel and equal in length, it transforms into a parallelogram. Now take that parallelogram. If all four of its sides suddenly become perfectly equal in length, it turns into a rhombus. But if instead all four of its corners snap perfectly upright to 90-degree angles, it becomes a rectangle. And what happens if you combine them? The ultimate shape, a square. A square is incredibly special because it is simultaneously a rectangle, a rhombus, and a parallelogram, all rolled into one perfect package.
So remember a moment ago how we needed exactly 3 specific measurements to lock down a unique triangle? Well, to construct a unique quadrilateral, you actually need exactly 5 specific measurements. That could be something like 4 sides and 1 diagonal, or maybe 3 sides and 2 included angles. Why? Because if you just nail 4 pieces of wood together, the frame will just wobble and shift around. Without those 5 specific data points locking it down, your 4-sided shape won't hold its unique form.
And that brings us to our final stop, Section 5, Perimeter and Circles. This is where we measure those boundaries.
Let's completely break away from straight lines for a minute. What's absolutely fascinating about the anatomy of a circle is that it's just a path of points that are all the exact same distance from one single central dot. That fixed, unchanging distance from the center to the edge is called the radius. Now, any straight line that connects 2 different points on the circle's edge is called a chord, but if that chord happens to pass dead center through the middle of the circle, it gets a special name, a diameter. And here's a fantastic geometry fact for you. Every single diameter is technically a chord, but not every chord is a diameter. Oh, and if you just look at a small curved piece of that outer boundary, that's simply known as an arc.
Now, when we want to measure the physical size of these shapes in the real world, we use the concept of perimeter. The perimeter is incredibly simple to wrap your head around. It literally just means the total length of the outside boundary. Imagine you're outside and you physically walk along the outside edges of a shape until you got right back to where you started. The total distance you just walked? That is your perimeter.
When it comes to mathematically calculating that perimeter, you just need a few really basic formulas. For a perfect square, since all 4 sides are identical, the math is easy. It's simply 4 times the side length. For a rectangle, because the opposite sides match up, the formula is 2 times the length plus the breadth. And when we jump over to circles, we actually give this outer boundary a special name, the circumference. Its famous formula? 2 times pi times the radius.
Well, how was that? A full journey from a tiny, dimensionless dot in space all the way up to complex shapes and formulas. I've got a fun little challenge for you before we wrap up today. Look around the room you're in right now one more time. Can you spot a physical line segment, maybe on the edge of a table, or an acute angle hiding in the corner of a window, or a specific quadrilateral lying on your desk? Math isn't just something trapped in boring textbooks, it is literally the structure of absolutely everything around us. So stay curious, keep exploring your world, and that's all for today's Explainer. Catch you next time!